Okay, everybody, so I'm going to try and do this one here on the board a little bit. Still try and give you some visual stuff. So what we're going to talk about right now is about angles, and there are different names and types for angles. So I'm going to give you these. So we're going to start here with this. Let's say this angle right here, and then this angle right here. If this angle here, we can call that angle A, and this angle B, because again, there's only one letter coming off of each one of them at the vertex. If this one's 60 degrees and this one's 30 degrees, then these two angles are called, special name, complementary. Okay, complementary. I believe you guys can do this. Keep that straight. So a 60 and a 30, so the two angles, angle A plus angle B, add up to 90 degrees. They're called complementary. Now, if I have this one right here, and this one right here, if I could take this angle and shove it right into that little spot so that these two rays were opposite, then those two angles, let's call this angle C and angle B. Angle C plus angle D adds up to 180 degrees. Then those two angles are called supplementary. Hopefully that you guys can see that okay. We got a Christmas tree on there too. Angle C plus angle D adds up to 180 degrees, and those are called supplementary. Okay? So, we also have a few other names. So, one of the things that we have is that if these two angles are right next to each other like this. So I've got the angle that's the dot and the angle that's the little triangle right there. If these two angles right here touch each other like that, or they share a common ray in the interior of the other ones, these two angles are called adjacent. And they have to share that common ray. Okay, in the middle? Good deal. So what happens if we have two of these that are adjacent, like this, and when added together, they're supplementary. So adjacent and supplementary. Adjacent and supplementary. We give that a special name. We give them something called a linear, because it forms a line, a linear pair of angles. Okay? So we're going to talk about linear pairs, we're going to talk about adjacent, complementary, supplementary, and then the final thing that we're going to talk about is, well, what happens when you have two angles that kind of cross, just like this? Well, these two angles, surprisingly, hopefully this makes sense, they're the exact same measurements. And these two ones that are right here, these two circles, those two angles are the same measurements. So anytime you have intersecting lines, it's going to form two pairs of congruent angles. These ones and these ones. And it kind of looks, this might be funny, might not be funny, kind of looks like a V for each one of those angles, right? So these angles, the two dots, are called vertical, even if they go side to side. And the two up and down ones are also called vertical angles. So we get vertical angles anytime it's like you get a V and a V next to each other. Okay? So how are we going to use all of these descriptions of this stuff with some of our math? Okay? So now I'm going to go back to the paper here, and I'm going to show you some things, and I'm hoping. Okay? So here, let's go around and do some algebra stuff. So let's say that I had this and this, and I had this angle right here, which was 6x plus 2, and this angle right here, which was 3x plus 20. And I'm just making this stuff up. So I got a 6x plus 2 and a 3x plus 20. And then let's do this one. Let's go 4a plus 6. And we're going to go to b minus 7. So those are Those are all the measurements of my angles that are in this expression. Well, I know, because these two lines cross, that I have vertical angles. So I know that this is true. So here's some facts. Due to vertical angles, I know that 4a plus 6 equals 6x plus 2. Yeah, that's true. But what does that tell me? I have one equation and I have two different variables, and you guys know going through math, right? That you can only have one different variable, and if you have two variables, you got to have two equations. Well, I only have that one. So even though this is a fact, this is true, I don't know that that helps me. Okay? So let's try another one. So because of vertical angles, I know that, write this one out, that 3x plus 20 equals 2b minus 7. That's true also. That's awesome. But I got an x and I got a b in here, and that doesn't do me any good. That's not 28, that's a b. So 2b minus 7. So that doesn't do me any good. So now I have two equations, but this is an a and an x, this is an b and an x. So even if I'm doing some advanced math, that still doesn't do me any good. So that means that vertical angles, even though it might help me in the future, doesn't help me now. Okay, so what other facts do I know? Look at these two angles right here. Did those two angles form a linear pair? The answer is yes. So by a linear pair of angles, remember linear pairs aren't equal. It's obvious, right? This one's less than 90, this one's bigger than 90, right? Less than 90, bigger than 90. But by a linear pair, I do know that this is true, that 3x plus 20 plus 6x plus 2 does add up to 180 degrees. And now I look at this and I go, hey, this is one equation with only x's in it. I can solve that. Sweet. So if I can solve this for x, let's try it. So I get 9x plus 22 equals 180. Excuse me, a lot of dust in here. Subtract the 22, and I get 9x equals, if I subtract 20, that's 160, subtract 2 more, that's 158. Divide by 9, handy dandy calculator here, 158 divided by 9, and I get x equals 17.5, repeating. Looks like I've just had, over the last few videos, several times where I had repeating things, which is probably good that all our numbers aren't perfect little nice numbers, because in real life they're not always perfect little nice numbers. So there we go, 17.5. Well, if that's what x is, then I could do this. I can store this in x. Remember, that's the little STO key, store, and then type x. That's the variable right there, stored in x. Hit enter. And if I want to know this expression, 3x plus 20, I can do that. 3x plus 20, and I hit enter. I know that that's 72.6 degrees repeating. Cool. If I do 6x plus 2, enter, I know that's 107.3 degrees repeating right there. And surprisingly, guess what? These two things add up to 180 degrees, because they're a linear pair, and you can check the two numbers, they actually do. Now if I wanted to find out what b was, I could still do that, because I know that 2b minus 7 equals, these are vertical angles, it equals 72.6 degrees. And then I could add the 7 and divide by 2. So 72.6, just put a whole bunch of them in there. Plus 7, enter, divided by 2. Enter. I know that b equals 39.83, where the 3 keeps going on and on forever. Likewise, I can do this. I can write this, 4a plus 6 equals 107.3, repeating, and I can solve that for a. So the big point on all of these is, whichever set of angles that you're working with is, know the relationships. Okay, so If they're vertical, we set them equal to each other. If they're a linear pair, we add them together and set them equal to 180. If we don't have expressions that work because they have two different letters, maybe there's something else that we can do. So again, we also have complementary and supplementary ones. Complementary means they add up to 90. Supplementary means that they add up to 180. There's a great picture in your book on page 48, that explains complementary and supplementary. Goes through some of these different ones. Same thing again, what a linear pair is, what vertical angles are, and finding angle measures in linear pairs. So let's take a look at some of the pictures here. Okay, so here we go. So on these ones right here, these set of angles, numbers right here, 1 and 2. So angle 1 and angle 2 form a linear pair. Angle 2 and angle 3 form a linear pair. Do angle 2 and angle 4 form a linear pair? And the answer is no. Okay, because they have to be adjacent. And in order for them to be adjacent, they have to share a common vertex. And you can see that 2's vertex is right here, and 4's vertex is right over there. Okay? Now, are 1 and 3 vertical angles? The answer is yes, they are vertical angles. And is 2 and, let's call this x, 2 and x, are those vertical angles? Yes, those are vertical angles. 4 and w, are those vertical angles? Nope, but they are a linear pair. So as you go through some of the homework in here, there's going to be some where it just asks you to identify certain things. Like right here in this picture, 3 and 5. 3 and 5 are not vertical angles. 3 and 5 are not vertical angles. The reason is, here's one line, yes, but if I was to extend this line, it would end up down here, and that's a broken line. So in order to get vertical angles, you have to have two lines that intersect, just like what happens down in here. And then you'll see a bunch of problems where they ask you for things. So your big picture stuff, right? Big picture is, are they equal? Do they add up to 90 degrees? Do they add up to 180 degrees? Or is there nothing that you can do with them? Okay. So the more you know all of these angles, the more you can write true algebraic relationships, which we call equations. And once you do have the equations, you can use your algebra skills to solve for them. Any help? Okay. So if I gave you this right here, if I said that angle BAD is equal to 3x minus 6, and angle CFW is equal to 7x plus 16, and I said that these two angles were supplementary angles, find the measure of angle CFW. You should be able to do that. So there's some of you, and I'm not saying you in particular, but students over years and years and years would write this. They would immediately go, oh my gosh, I did this just a little while. 3x minus 6 equals 7x plus 16. They'd write that. No, don't let that be you. That is not true. Supplementary doesn't mean that the angles are the same, right? Congruent means that those angles are the same, right? Supplementary means they add up to 180. So I'd have to write 3x minus 6 plus 7x plus 16 equals 180 degrees, and then use my algebra to go ahead and solve that, and then I could stick it into there. Good deal. So this is, again, all these videos are quick little synopsises of section 1.6. Hoping this helps. I will talk to you later, Mr. Bells.